Hey guys, as of right now, you should be able to find the principal value of any inverse function. And today we will be looking at the general solution of those inverse trig values. Now, the definition says x equals cosine inverse of 1/2, and you can read it as cosine of x equals 1/2. That actually tells you that there is a certain angle whose cosine is 1/2. Here's my cosine graph. Let's say we're trying to find out all those angles that whose cosines are is 1/2. So I will go ahead and draw a line here at 1/2, and if I draw it correctly, here's my line at 1/2. Now I will go ahead and put a dot wherever is crossing the cosine graph, and on this specific one I have 4. Keep in mind, if I continue with my cosine, I will have more than 4. The first one lands on -60. I have it at 60, 300, and 420. Now, I will look for the difference between the first and the third value of cosine of x when it's 1/2. If you look at this difference, you will do 300 minus -60, and if you do 300 minus -60, that difference should be 360 degrees. Similarly, if you do the difference between the fourth value, which is 420 minus 60 degrees, you will do 420 minus 60, you will get another 360 degrees. Do you think the difference between every other value of x is 360? Let's figure it out. In fact, that distance is actually a period, because if I move from the first one and I travel all this distance and I get to this other point, I actually travel a whole period. So the period is 360. So I would say that difference will remain 360 degrees because that's my period. Let's go ahead and move on to something else. Now, if I say that you should look for the value of the fifth dot, knowing that the first one is at -60 and the second one is at 60. The first one is at -60. To get the fifth one, all I need to do is add 360 degrees twice, because adding 360 will give me to my third dot. Another 360 will get me to my fifth dot. So for the fifth one, 360 plus -60 plus another 360 will give me 660 degrees. If I do the same thing for the sixth one, I will get 780 degrees. Number of value of x by adding a multiple of 360, you should get all of them. Thus, the general solutions are 60 degrees plus 360 n, or -60 degrees plus 360 n. Actually, I should say and, because those two are important. Let's look at the cosine of x when is equal to square root of 3 over 2. We will be looking for the general solution and the first three positive value. Let's start with the principal value. Cosine is made from the adjacent and the hypotenuse. This is a 30, 60, 90 degrees triangle in the first quadrant, and adjacent of square root of 3, then we have a 30-degree angle, or of course pi over 6. Now, if that value is on the graph of y equal cosine x, then what other negative value is also on the graph? Of course, it will be our -30 degrees or negative pi over 6. So to find the general solution, I will say that the general solution will be x. Since we're talking about x, I will leave it in degrees, and it's like a system. X is equal to 30 degrees plus the period here is 360 n, or -30 degrees plus 360 n. Let's go ahead and find the first three positive value. The first value is always from the positive angle, meaning this. In case you put 0 here, you get 30 degrees. The second one, you don't want any negatives, so since we say the first three positive. So I will not worry about a -30 by putting 0. So if I can't put 0 here, I will plug in 1. If you plug in 1, you get 360 minus 30, and you should end up with 330 degrees. Now you go back to the previous, you gotta keep going back and forward. If I go to this one and I plug in 1, I get 390 degrees. Those are my first three positive values. But if you keep going, of course, you're going back to the other equation, you get 690 degrees, and so on. Now, let's do the same thing for sine. And this time, I want the sine to be equal to 1/2. I will complete this by doing the exact same thing I did on the previous one. So I'll graph a line at 1/2. I will go ahead and put dots wherever is equal to 1/2, meaning somewhere. I'm sorry, erase that first dot. Meaning at 1/2 would be here, 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 and here. So the values are 510, 390, 150, and 30. You can see this on your paper already, so I will go ahead and go on, complete the bottom. Keep an eye on your graph. Now it says every other dot still has a difference of 360. It will be very similar to the one we just did for cosine, and that's of course our period. And both y cosine x and y sin, they are how many values of x per cycle on the graph. We will have 2. Does occur at 150 or 180. And once you have the first 2 values of x, when can you find an infinite? How can you find an infinite number of value of x? By adding a multiple of 360 degrees. You will write the general solution the same way, meaning open the bracket, you will say x equal. You write the first x value, which is 30 here. And of course, it's plus 360n. And here it will be 150 plus 360n. Let's go ahead and move on to the next portion. The next portion says sine of x is equal to the square root of 3 is equal to square root of 3 over 2. Find the general solution. Find the first 3 positive values of x. Now, the principal value of x when the sine is square root of 3, knowing that this is the opposite and this is the hypotenuse, we know that this is a 60-degree angle. And if you take away that 60 from 180 to get the second value, you should get 120. Now that you have 120 and 60, if that is on the graph of y, then what other value? Of course, it's 120 here. Therefore, the general solution would be x equal and x equal. The first one will be 60 plus 360n, and the other one will be 120 plus 360n. Use these integers. Let's go ahead and find the first 3 positive value. The first one, of course, is 60. The second one is 120. The next one, you're going to get it from this equation by plugging in 1, and you should get 420. And if you keep going, the next one will be, if you plug in 1 here, you're going to get 480. And you go back to the first equation and so on. But all we needed was the first 3. All right. What about tangent now? For tangent, we want the tangent of x to be equal to 1. So if I go ahead and graph a line like I've been doing at 1, meaning here, or somewhere there. Here's my line at 1. Let's go ahead and find out where exactly does it cross with the equation or with the tangent graph. That's the first point, second, third, and we can't see the other one. So these are the values that we have so far. We have negative 135. We have 1 also at 45, 1 at 225, and so on. Now, how many times per cycle does x? We only see it once. Only one time every cycle. And how often? How often do we see 1? It's every 180 degrees. Keep in mind, that's the period of our tangent. The period of tangent is 180. Sine and cosine are the one with 360. Now, then you can find an infinite number of values if you keep going. If you keep adding what? That would be my 180 degrees. So the general solution would be x is equal to, this one started around, the first positive one here is 45, so I can say 45 plus 180n. All right, let's continue to the next page. The next page now we have an example of tangent. Tangent of x is equal to square root of 3. So this is the same thing as x is equal to the tangent inverse of square root of 3. Keep in mind, this is square root of 3 over 1. So the adjacent is square root of 3, and the opposite is 1. The principal value here is 60 degrees. I would call it PV, and that's 60 degrees. Now, because it's 60 degrees, I have the general solution would be 60, or x equals 60 degrees plus 180n. Now, for the second one, it says find the first 3 positive values of x. So the first one is of course 60 degrees. The second one is, in case I plug in 1 here, I will get 240 degrees. And if I plug in another one, I will get 420 degrees. What if I say that you should solve it in radians? Usually I say theta is equal to pi over 3 plus pi n. And the first solution would have been pi over 3, followed by 4 pi over 3. If you keep adding pi to it, pi is actually 3 pi over 3. And if you add another 3 pi over 3 to this, you get 7 pi over 3. All right, I have this, we need to go ahead and look at these few problems. But before we get to those few problems, let me go ahead and summarize what we just learned. Let's go over the problems. Now I'll summarize it. A quick summary. If we're talking about cosine, for cosine, x is equal to plus or minus the principal value plus 360n. If we're talking about sine, I would say, let's change colors, sine here, I would say x is equal to principal value plus 360n, or of course keep in mind, instead of 360 you can also say 2 pi n here, or you can also say on 360 here 2 pi n. Every 260 can be 2 pi n. So the second portion of the sine, you will say x is also equal to pi minus the principal value plus of course 360n. Now, if we're dealing with tangent, that's a lovely one because it's also one single equation. You will say x is equal to, by the way, instead of pi, you can also say 180 degrees. Here you will say x is equal to 180 degrees minus the principal value plus, no, this is I'm doing again sine. We say tangent. Tangent is nothing other than principal value plus 180n. So I will say PV plus 180n. Of course, 180n is the same thing as pi n. All right, let's look at these few problems. We have about 3 minutes to look at these problems. For the first one, sine, knowing that this is the opposite, this is the adjacent, and I know also that this is negative. So for sine, it's the belly. Negative means it's on the fourth quadrant, is in this quadrant. So all I need is to find the principal value and put a negative in front. Opposite the square root of 3, so PV is equal to negative pi over 3. Now that I know the principal value is negative pi over 3, knowing that I'm dealing with sine, I will say x is equal to principal value, meaning negative pi over 3 plus 2 pi n. And the second one, by the way, you can put theta here. The second one will be theta is equal to, remember, we do put pi minus the principal value. That will give me 4 pi over 3 plus 2 pi n. Now the first few values that we can get, by the way, this is A, and to find B, I will say the first value will be, of course, 4 pi over 3, which is the positive one. And if I plug in 1 here, I will end up with 5 pi over 3. And if I plug in another one, I will get 10 pi over 3. Let's do the same thing for problem number 2. All right, let's deal with tangent. Tangent of x is equal to negative square root of 3. I know it says x here, although I'm solving it in radians, but you can always, I can change this one in theta and solve it in radians. So this one is tangent of x is equal to negative square root of 3. I'm going to change it into theta again to get it in, all right, x is in radians. So let's go ahead and find the principal value. The tangent is square root of 3 over 1. Therefore, the opposite is 1. Opposite is square root of 3 and the adjacent is 1. Opposite being square root of 3, the principal value is negative pi over 3. Remember, tangent is the belly, therefore is in the negative side, meaning on the fourth quadrant. So to find the general solution, I will say x is equal to negative pi over 3 plus pi n. Now, the first value will be 2 pi over 3 in case I plug in 1. The second one will be 5 pi over 3 in case I plug in 2. And the last one will be 8 pi over 3. I should leave one for y'all to do. Maybe I should leave y'all the last one. Let's do the secant. Secant, cosine his brother secant lie on the card, and it's negative, so it's in this quadrant, meaning the second quadrant. This is over 1. Therefore, the hypotenuse is square root of 2, and the adjacent is 1. Therefore, the opposite is adjacent and opposite will be 1. That's a 45-degree angle. In this quadrant, instead of 45 degree, I will do pi minus pi over 4. And if you do pi minus pi over 4, you end up with a principal value of 3 pi over 4. Now, because it's cosine related, all I need is a plus and minus. That's x equal 3 pi over 4 plus 2 pi n. And x equal on this one, it will be negative 3 pi over 4 plus 2 pi n. Let's go ahead and find the first few values. The first one will be, of course, 3 pi over 4. The second one will be 5 pi over 4. That's in case you plug in 1 in here. And if you plug in 1 on the equation on top, you get 11 pi over 4. I'll go ahead and do the last one anyways. This is the sine, therefore the opposite is 1, and the hypotenuse is 2. Sine is the belly, located in the fourth quadrant since it's negative. The angle will be opposite 1, negative pi over 6 is my PV. Now, because it's sine, I know that one of them is negative pi over 6. The other one, I need to take it away from pi. So I will say x is equal to negative pi over 6 plus 2 pi n. And the second one will be x equal 7 pi over 6 because I do pi minus pi over 6 plus 2 pi n. That's my general solution. First solution, it will be 7 pi over 6 because that's a positive 1. Then I will plug in 1 over here, and I will get 11 pi over 6. And I will plug in another 1 over here and get 19 pi over 6.